I have a suspicion that some of you care a little bit about saving money. So I'm glad you're here. Welcome to the session. We are deeply, deeply passionate about saving our customers money, and we're excited to talk about that today in this session about optimizing costs and increasing efficiency. My name is Kaustubh. I go by KD. I'm going to be joined by Krish, who's going to join me on stage in a little bit. And with that, I'm going to dive into our conversation here. So we're going to talk about 4 things. The first is about controlling costs, which is so central to everything we do in the cloud. The second is about putting your right VMs in the right places. Then we'll talk about GPU access for AI ML, a topic that showed up in the keynote, and we'll talk a little bit deeper about it in the session. And finally, the other thing we're super passionate about is user experiences and console experiences, and we're going to end with that. OK. So I'm going to start with a customer of ours, the story about a customer of ours. And this customer is a large ISV that started off with us a number of years back. And they started off using a number of N1 VMs. There were about 60-40 between N1s and N2s at a certain point of time. And then once they got a sense of what their steady-state spend was, they went to 80% CUD coverage to deeply reduce the money that they were spending on the cloud. Over time, this ISV realized that since they were serving end customers, they could move to later generations of VMs and reduce their spend even further. They moved to N2Ds and N2s. And then they said, well, this pattern is going to happen again and again in the future, and they moved to a mix of flex CUDs and CUDs. They ended 2023 with upping their usage by about 40%, because that's how much their business was growing, and then ending at about a 97% CUD coverage. And that's the pattern that a number of you will go through. A number of our customers go through that pattern. They start out early with bursty workloads or just early workloads. Then they start to get to a stage where they're growing, but it's not fully planned in terms of what their growth is going to be. They use flex CUDs, perhaps. They use a mix of CUDs and flex CUDs. And then they eventually get to a steady-state pattern where they're using all of these consumption models. So we're going to talk about all of these, some of the new features in these. But some of you are wondering, what is this CUD? What is a CUD and a flex CUD? Others are super familiar with this. So I'm going to spend a few minutes on just explaining these terms, just for those who haven't heard it before. So we have a number of consumption models. Obviously, on demand. You got CUDs, which come with a deep discount, 37 to 55%. You got flex CUDs, which are a spend-based commitment but allow you flexibility, and I'll talk about what that flexibility is. And then, obviously, spot VMs, which are the deepest discount of all, but they are preemptible. OK. Resource-based committed use discounts, or CUDs. These are deep discounts in exchange for a committed term. What are they good for? They're good for predictable, steady-state workloads. They apply to an aggregated resource of compute, memory, local SSD. And uniquely different than a lot of others, they're fully transferable between machine sizes or operating systems. And obviously, they apply to GKE usage or data proc usage. OK. The next thing we talk about is flex CUDs. Flex for flexibility. What's it flexible on? It's flexible on VM families. It's flexible across regions. And these are also good for predictable spend, but where you desire that need to maybe rapidly transition to the next VM as soon as it comes or pretty soon after it arrives. And that's what these are really, really good for. Similar to CUDs, they're fully transferable between machine sizes and operating systems. And I'll talk about the billing account in a little bit. OK. So CUDs, by default, apply to the project where you bought them. However, by turning on billing account sharing, you can have them be attributed to multiple projects within the same billing account. OK? And this can be in two modes. It can be either proportional attribution, or custom. And as the diagram shows, if you have two different projects with two different levels of usage, you can proportionally split the card across those two. So team A is using less. It gets less of the card discount. Team B is using more. It gets more of the card discount. So that's a useful way to do it. But some of our customers want to have more control on this spigot. So you can also define a custom attribution where you define your own business logic that splits the discounts. And one of our customers, a very acquisitive ISV, has been acquiring a number of different companies over time. And when they do that, they find that some companies have certain usage patterns, others have different usage patterns, and they like this feature to be able to custom control how they attribute the card across those acquired companies. Now, CUDs are great, but we have a number of features that make CUDs even easier to use. And in particular, the auto-renew feature saves you time from dealing with CUDs and managing them so that you can focus on your business logic. And like it sounds, just tagging it auto-renew, marking it like that, it's a buyer action, release your developer teams from having to worry about renewing the CUDs or when the CUDs expire or when my spend is going up. They can focus on the business logic. Term upgrade. You can do this anytime, and you can upgrade your one-year term or your three-year term up to a 3-year term and enjoy deeper savings. Splitting and merging. So they are, again, what they sound like. Projects have different needs, and you can govern the usage by that project by taking a cut and splitting it into two parts across projects that have different needs. Similarly, you can merge CUDs together. And the question that comes up is, what happens to the timeline of the merge? And you basically co-term the CUDs as you merge them. So it, again, drives that simplicity in managing these discounts. And finally, some of you wanted longer-term CUDs, because as you're migrating from on-prem, the depreciation cycles of on-prem sometimes match a much longer duration than the cloud, and you wanted terms that extend beyond the 3 years, beyond the 1 year. And this is coming soon to extend your lifetime of your CUDs beyond the 1 year and 3 year boundaries to match your business needs. There may be a variety of reasons to do this. OK. So I've talked about a number of tools to help save money. But how do you know how effectively you're using those tools? How do you know what is the level of waste potentially in the system? How do you right-size your workloads? And more importantly, we all love saving money, but we want to get credit for it. How do you celebrate internally the fact that you all have saved money? And that is why I'm excited to announce that the FinOps Hub is now GA. And let me talk to you about what this does. So the FinOps Hub does 3 basic things. First, it allows you to better instrument, operationalize, and optimize your spend, and that is through this FinOps maturity feature. The second thing you can do, and this is something that comes from the power of being in the cloud, is to benchmark against your peers. How effectively am I using my spend compared to my peers? And peers defined in a variety of ways. And finally, nobody wants to stare at dashboards. You want recommendations that are actionable, that can actually save you money right now. And that's what the third pillar does, is to give you recommendations that allow you deeper savings. So let's talk about the FinOps maturity. You get a score. What good is the score? The score is a visual to help you orient yourself towards certain actions. Now, what are these actions? These actions fall into three buckets. Inform. Inform is allowing your teams to have the data they need by giving them permissions, by exporting some of these usage costs to BigQuery, by tagging or labeling them. You can empower the broader team to also participate in the cost optimization process. Second, to optimize, apply cards, right-size instances, and finally, operate. I want to know when I'm hitting certain boundaries. How do you set alerts or budget alerts to help you better manage your costs, to better manage your spend? OK. Benchmarking. The power of the cloud is that your peers are also in the cloud. And that source of anonymous data, rich but anonymous data, can help you benchmark how are you managing your spend versus some of your others. And that may be on an industry cut, a workload cut, or just a level of usage, level of scale kind of cut. And this helps you say, well, how good am I at doing this? There may be special circumstances that allow me to be different or need me to be different, but it gives you a sense of how you're doing versus your peers. And finally, recommendation. This is where things get really powerful. The system analyzes your usage patterns and recommends, based on your spend, based on your usage, based on how your spend is projected, what you should do to save even more. And when it says, this is what you should do to save even more, you can actually scenario play it. And that is what I find really powerful, to be able to say, well, if I did this, what would happen? And that allows you to then actually model out your savings, click a button, and realize your savings. And so I'm going to leave you with a page which you can explore later on about all the different kinds of recommendations. And these are only the ones for the compute side that you can use to optimize your spend. Not enough time in this talk to go through each one of them. But now I'm excited to welcome Krish.
Thank you, Katie. As Katie mentioned, saving money is super important for all of us, personally, professionally, in the cloud, and otherwise. And there are multiple tools, as you just learned, that allow you, some of those tools that you might already be very actively using, but there are new ways in which you could begin to surface information that allow you to make decisions. So the FinOps Hub that Katie just announced is one example of a way in which you could go ahead and then do that. So we're going to shift gears a little bit and talk about a few other things. Ultimately, what you use the cloud for is about your workloads. So we're going to spend some time in talking about how do we optimize your workloads in making sure that we've got the right VMs in the right places that are in the right position to service the workloads that you care about. So let's dive straight in. The first part of any optimization journey is typically about choices. So the more choices that I have and the wider or sometimes deeper those choices are, the better I am. However, just having choices by themselves is not the ticket to excellence in optimization. You need to have control over those choices and making sure that we have simplified controls. So flexibility provides the choices, and then we need to have simplified ways in which you could go ahead and then control those choices in such a way that you could actually apply those choices effectively against your workloads to get the best benefit out of your optimization journey. And lastly, we want to make sure that things are predictable, because ultimately, most of you, if not all of you, run mission-critical businesses, and we want to make sure that flexible and simple-to-control choices are ultimately predictable, particularly from a capacity standpoint. And we'll kind of talk about all of this, and we have some exciting new news to share in all of these areas as we go along. Let's first talk about flexibility and virtual machines. There are several dimensions by which your virtual machines can be flexible. And here's an example of 4 of those. And we'll talk about each one of them in sequence. The first one is about location. So which region, which zone am I deploying my virtual machine is an important consideration from a workload perspective. The second is instance-level flexibility. Today, and through the course of this session, you're going to hear about our portfolio of VMs growing significantly. There are some super exciting announcements that are coming in, but as that portfolio of VMs or instances or families of instances keeps growing, how do we make sure that we're retaining the flexibility to choose among them really well? We'll talk about that as well. And the third part of flexibility is the consumption model. Katie, in his part of the talk on cost, talked about things like on-demand VMs and spot VMs, and what are the mechanisms through which you could go ahead and then flexibly choose between those choices available for you. And last but not least is about time, because not every workload needs to run instantly at this very moment. And in particular, we'll talk about time in the context of GPUs, which are a very scarce resource today, and how best we could use time to our advantage in ensuring that our workloads that need GPU power can get it at the time that we want them to. So let's jump right in. Let's talk about location. So the first part of location is about zone flexibility. So a VM can live in any given zone in a region. But any given zone in a region is sort of a very broad set of choices, and we need to be clear in terms of what our workload really cares about. Perhaps your workload cares a lot about obtainability of the resources, meaning I want to make sure that if I'm going to go ahead and then deploy 80 VMs, I can deploy 80 VMs. So go ahead and then distribute them across zones in such a way that I could follow the capacity that's available in those zones such that I'm always going to get my 80 VMs when I need them. That's one way of actually providing zone flexibility. Another one could be about performance. You want things to be distributed enough in such a way that your overall network performance is also distributed across zones, so the aggregate throughput and bandwidth that you're actually getting across the collection of VMs that you have is the best possible. There is a policy for that, and we'll kind of talk about that as well. The third could be about reliability. So you want to make sure that you're protecting yourself and you're protecting your workloads against any sort of zonal failure. Our zones are pretty resilient, but you always want to make sure that you architect things in such a way that you're architecting against any potential failure. So it could be about resilience in making sure that we can go ahead and then have them distributed to provide the best protection against any kind of failure. So there are several different ways we could go ahead and then do them. So the examples that we show here are ways in which managed instance groups, which are basically a collection of VMs that are acting as one VM at the end, can avail this zone flexibility in multiple different ways. We have policies going back to the controls that you can actually have on that flexibility. There are 4 policies that we have available. Sorry, let's go back. There are 4 policies that we have available: even, balanced, any, and single any zone, that provide you that control over how that location or zonal flexibility is going to be manifested for your workloads. So zonal flexibility has been in GA for a little bit of time. It's hugely popular with our customers. In the last about 18 months of its existence, about 59% of all of our managed instance groups today get deployed as zonally flexible. So it kind of shows the power of what this location flexibility can mean to you and your workloads. Right? So certainly look it up. Announcing today is instance flexibility. We're very excited to add the next 2 dimensions in this flexibility journey through instance flexibility. The managed infrastructure group that we just talked about, which is a collection of VMs that operate as a single entity, up till now has always been a homogeneous entity, meaning I pick one instance, and then that instance is going to be replicated n number of times, and that's what I get as a managed instance group, and that was it. Well, that isn't too flexible, is it? So what we're introducing today is the ability for you to mix and match your instances within a managed instance group. And we'll talk a little bit about detail on how that works. But it doesn't stop there. Much like how we're introducing the instance flexibility, we're also introducing consumption flexibility as part of that offering, which means now I have the ability to control how much on-demand use do I want to have in that managed instance group, and then how much spot do I want to have in that managed instance group in such a way that I can control the amount of critical workloads that I want to have, or the scale of critical workloads that I want to have in that managed instance group, and the cost savings that I could actually get by committing to spot VMs for the remainder. You have control over what that ratio looks like, so you could decide how much critical VMs, how much cost savings, and sort of flexibly move between the two. So instance flexibility in 2 dimensions, doing both VM level or VM family level flexibility and consumption flexibility. Let's take a look at how this works. So there are, of course, in every Google Cloud capability, we've got ways in which you could do G-Cloud and API, Terraform type of access to that. You can, of course, come in through the console and kind of manipulate things. I'll take an example of the CLI for a quick second. So the way you describe your policy and the control that you want to have over that policy is super, super simple. You simply say, hey, I want to take these collections of VM families, group them together, and then say, my managed instance group can actually be in any of these VM families. Go ahead and then create them. If you run out of the first one, go to the next one. If you run out of the second one, go to the third one, so on and so forth. You could also rank them by the groups so that you could prefer a set of VMs because you know that they are giving you the best price performance up front, and the system would automatically choose those over what else is available for you. If for any reason you run out of rank 1 is really when rank 2 comes into play, and so on and so forth. So you could indefinitely go ahead and then stack them as much as you want. And similarly, you could go ahead and then define the ratios associated with what you want to do with your on-demand VMs and spot VMs, and the system would go ahead and then get your on-demand VMs provisioned first, because those are critical for your workload. And then as capacity becomes available or is available, go ahead and then fill up the rest of it in that ratio with your spot VMs as well. That entire process is automated through the managed instance group console and the CLI. Moving from there, it's nice to have all of this flexibility in VM creation. We talked about zones, we've talked about instances, families, and we talked about consumption models. But ultimately, we want to make sure that there is capacity for all of that. The cloud is elastic, which means there is quite a bit of capacity that's around. But there are times that your business demand could actually be going up and down. Or at a minimum, you want to understand how best you are using the capacity for yourself. We're very excited to introduce Capacity Planner. That's actually going in for our premium support customers right now. And what this provides is 2 big things. Number 1 is an aggregate view of all of your historical capacity usage, such that if you are in a multi-project, multi-org, or even multi-developer setup with Google Cloud, you're able to go ahead and then take a look at the total view of all of the things that are happening from an overall capacity usage standpoint. That's on the left. So a little step function graph for this particular customer kind of shows how their usage has been growing. In some cases, there are small drops and sort of step function to the right all the way. But it doesn't stop there. To the very right, there is also a predictive view. Today at the keynote, how many of you were actually made it to the keynote session inside? Lucky you. I think many of us actually did the overflows. But nevertheless, if you count the number of times AI was mentioned in the keynote, I'm pretty sure it's probably going to close to the number of people in this room. But I'm going to do it one more time for you, probably a few more times later. We do use AI to analyze what your historical usage trend is and provide a view for you to predict what your usage pattern is going to look like in the future. That's a prediction based on your own data. However, it's quite possible, just like they say in the stock market, past performance is never a guarantee of future. Your past performance may actually not reflect new business needs that you have. So this prediction is something that you could take a look at and then say, hey, this sort of lines up with what I want to do because this is sort of how my business has been trending all along. Or you could say, no, I want to make a change to this because there is a change in my business needs that's requiring me to deviate from the pattern that I've actually shown in the past, and then this is sort of what my new pattern is. You could go ahead and then make that change. And a few things that also come in with that is a fully customizable, detailed view, literally by VM, by region, by zone, by shape, of what exactly you're consuming. So those graphs in the previous page look very nice, and those are important from an aggregate view perspective. But this now gives you, at the project level and at the individual resource level, the exact thing that is happening all along. And you could trend each one of those individually as well. So you could learn from what your own past usage has been looking like so that you could predict and plan for the future. So knowing and planning. And the last thing is there are times where the usage is not going to be as smooth or as linear or as clearly step functioned as we saw previously. It's quite possible, and this happens with a lot of our retail customers. It happens with a lot of our gaming customers. And most recently, it's also happening with a lot of our Gen AI customers as well, where the usage could actually be unpredictable as there is a spike that's coming in that you can know upfront, and you want to be guaranteed that capacity at the time that that spike happens. And through the capacity planner, you could simply go ahead and then trigger a future reservation that then allows you to get guaranteed capacity for that ultra-critical workload that you care about, all from one place. So you know about what your overall capacity usage is, you could plan for the future, and you can actually go ahead and then do exception management on that, all from one place, and that's through Capacity Planner. Having capacity is good, having flexibilities is also good, but ultimately, from an actual usage standpoint, there are times that we run into some frictions. And quotas have been an area of friction that we've actually heard from a lot of you. We're also very excited to announce that we're introducing Resource Quota Adjuster. I'm going to do AI one more time. We've actually looked at your usage patterns, and based on your usage patterns, if you're a highly reputable customer, there is no reason for you to be held back with quota limits for your actual compute usage. Resource Quota Adjuster allows you to automatically enable the thresholds of your quota to go up or down, again, based on your usage, in such a way that you do not have to file a quota increase request to actually use your compute resources. We're super excited about it. At this point, it is an opt-in feature. So when you go into the console, you'll actually see the ability for you to turn on Quota Adjuster. And the moment you turn on Quota Adjuster, essentially your quota will begin to float above from a threshold perspective on your actual usage patterns, just ahead of that usage peaking in such a way that you're always having quota for what you need to use at any given time. Let's switch gears a little bit. I kind of talked a little bit about AI/ML and the fact that we're going to talk a little bit more about it. Also notice that when we talked about all of those dimensions of flexibility, we talked about location, through the zone flexibility, we talked about instances, we talked about consumption, but we never talked about time. So now is the time to talk about time, sorry. Why is that important in the context of AI/ML? Today, there is a significant shortage of GPU resources. I don't think anybody is new to that news. However, there is also an increasing demand in each one of your companies, each one of your enterprises, for doing a lot more AI work. How do we match the business demand that you have to run AI/ML jobs with the scarcity that's there in the GPU? We're very proud to introduce Dynamic Workload Scheduler. For those of you that have been in the keynote, you probably heard Amin Vadat, who is our VP GM of Core ML Infrastructure, talk about consumption modes and Dynamic Workload Scheduler. We're going to double-click a little bit more on that in order to make sure that we match you appropriately for your business needs for AI/ML from a workload perspective with the GPU capacity that you need to make that happen. How do we do that? The first part is providing a very simple interface that does not require you to reserve the capacity in long-term tranches to be able to go ahead and then run your workloads. Second is being flexible in terms of multiple different use cases that you might have that require different levels of SLAs associated with the AI/ML workloads that you have. And third is seamless integration with the set of managed services that we have on top, whether it's GKE, whether it's Vertex, or any other services that you may be using that require those GPU services or GPU resources, and being able to go ahead and then integrate with them flexibly. Let's dive a little deeper. We are introducing two different modes for Dynamic Workload Scheduler. One called Flex Start mode, and we'll kind of talk a little bit about that in a second, and another called Calendar mode, that each allow you to time defer the start of your AI/ML workloads to the time when GPUs become available in such a way that you're not in the position to have to go hunt for GPU capacity at any given time. The system does it for you. You simply submit your job, you submit your job requirements, and the system takes that in and then lines up the GPUs that you're needed for that job by itself, and then lets those jobs continue on those. Going forward a little bit on that. So what are the big advantages before we get into the next level of detail? One is, gives you the flexibility to burst into capacity that you otherwise may not have reserved and held. Second is schedules all of the GPU resources simultaneously. So it's almost like, I walk into a restaurant and I have 8 people that I want to make a reservation for, and the restaurant says, you know what, I've got to have three chairs available for you now, 4 available later. That doesn't work. You want to have all of those 8 people kind of have a seat at the table and enjoy the dinner. Your ML AI workloads work similarly. You want to make sure that you've got the right capacity that's available in a single tranche that allows you to go ahead and then execute your workloads really well as one entity. And the last one we'll talk a little bit about is enabling optimize the spending. So taking a restaurant analogy a little bit more, not all times do we reserve to get into a restaurant. We like a restaurant, we just want to go there and then say, look, just put me on a wait list. I'm willing to be there for a little bit of time. I don't know exactly when that wait list is going to clear. You tell me that it's going to take about 20 minutes, 30 minutes for the wait list to clear. I'm okay. I'm okay waiting for that. So let me in once that wait list clears and the table is ready for me. I'm ready to go ahead and then dine. Flex Start mode in Dynamic Workload Scheduler lets you do exactly that. You're now able to go ahead and then submit your AI/ML job with requirements associated with what GPUs, what shapes do you want, how long do you want them, and you go ahead and then submit that into the system, and the system takes that in, puts that in a queue, and then assembles the resources, the quote-unquote chairs and the tables associated with them for you, and once they are available for you, matches your workload with that capacity, and off you go. Very simple way in which you don't have to worry about reserving anything and able to go ahead and then still get the GPU capacity that you need. Calendar mode works more like your traditional reservation, but at the short-term reservation where you're simply taking what you need to do from a AI/ML workload perspective, but you have a very specific need. You need that job to start at a particular time, or you need that job to stop at a particular time because you've got other dependencies that you're working with that are important for you. A very classic example for that is cyclical training. Customers are fine-tuning their models on a constant basis, and they need to do that on some periodicity. And at that time that they want to get that done, they want the resources to be there. So if it's end of the week for a fine-tune that a retailer wants to do, that's what they want, because at the end of the week, that cycle keeps repeating itself. So for cyclical or other time-dependent ways in which you would want to use GPU capacity, what calendar mode provides you is a simple way in which you could go ahead and then acquire that capacity for a short period of time and then let it go once that particular job gets done. Both in Flex Start and in calendar mode, the big advantage is you only pay for what you use. In Flex Start mode, for instance, if you come in and then say, my job is going to be running for 20 hours, and then it needs 16 GPUs, H100s, and I'm going to go ahead and then put that request in for a region of your choice. The system takes it in, runs it, and let's say your model ends up finishing its training in 18 hours or less than what you'd originally intended for. You simply terminate those VMs at the end of your training job, and that's all you pay for. So it's almost like you go to the restaurant, similar example, you're waitlisted, you go sit in. Typically, the restaurant, you want to say, I'm going to be there for 2 hours. You're done with your dinner early. You can leave. So it's very, very simple in ways in which you can actually go ahead and then serve your AI/ML workloads, but also save money in that process. Get GPU capacity, save money, and be able to go ahead and then flexibly use your capacity from a time perspective. Very similar on calendar mode. If you're able to go ahead and then secure that capacity at 9 a.m. on a Tuesday, and you bring up that set of VMs, but your job is done, even though it might actually be scheduled for 20 hours, you can simply go ahead and then take that off earlier, and you get billed for what you would pay for. Right? That capacity goes back into the pool. It's getting ready for the next customer, and so on and so forth. So in very simple ways, we're able to go ahead and then get the overall GPU capacity that we have available for you lined up in a way that we could go ahead and then get matched with your AI/ML workloads. So we talked a little bit about flexibility. We talked a little bit about overall ways in which you could go ahead and then control that flexibility, apply that to AI/ML workloads. I want to invite Katie back up again. Ultimately, productivity for you as a user or as a developer is paramount to us as well. No optimization journey can be complete without the right tools for overall productivity. So Katie, if you want to talk a little bit about how we're working on that.
For sure. Thanks, Krish. So Krish and I are obviously deeply passionate about saving you money, but there's one more thing that we are deeply passionate about. There's one more thing, and that is simplicity. Simple experiences are powerful experiences. Just like in Google, simplicity and a simple way to consume cloud is what we can constantly strive for. So I'm going to talk about 3 ways in which we are making it simpler. And one of the ways is Coda, which was not simple. Krish talked about the Coda adjuster, which takes away a lot of the friction that you all have faced. And we admit it. You all have faced that friction. The second way we are trying to take away that friction is by giving you upfront Coda visibility. So at the time of creation of a VM, you will be prompted if you do not have Coda, and you will be able to then adjust that Coda to make sure through the same simple workflow, you're able to get started and get going. Krish talked about MIGs and the flexibility we are driving in MIGs. But creation of the MIGs could have been more simple. And that is what we are trying to do through this flow, which allows you to automatically scale a VM into a MIG right from the console itself. So you create a group, and through a simple workflow, through the console, just go ahead and create that MIG. The final piece is trying to make you avoid doing things that you don't have to do, trying to increase that obtainability. The any zone feature allows you to not have to worry about which zone to put this VM in if you do not actually care about it. Again, our attempt here is to make things as frictionless, as simple as possible so that you can get your developers or yourselves moving faster, moving more productively on our platform. So we talked about a number of ways in which you could save money through a variety of consumption models. We talked about how we're driving flexibility in helping you put the right VMs in the right places, powered by AI inside. We talked about how you can obtain AI resources and how you can save money while doing that through the dynamic workload scheduler. And we talked about simple experiences. But there are three things. I want you to maybe note it down, take a picture. There's three things you can do after this conference, after this talk, that will help you get started on that journey. And the first is log into the FinOps Hub. Log into the FinOps Hub, get started, learn how you're doing, start to take some of those recommendations. The second is optimize some VMs. Create some flexible VMs with the MIGs that Krish talked about. And finally, start playing around with the dynamic workload scheduler. Everybody has an AI use case, and you need the AI resources to power your AI use case. You can get that and save money through the dynamic workload scheduler. Three simple, easy steps for you to get started on this journey. And with that, I'm going to just leave you with some logistical things. Please take a picture of that to get special offers. And please give us some feedback. Give us a great score, or tell us what we could do better. We deeply value this. And with that, enjoy the rest of the show. Krish and I, thank you very much. Thank you.